Hi guys and welcome back. In this video we're going to learn about pack. Pack, you can think of it as putting the components in the window where they fit, given that they adhere to certain constraints that we give it. Pack can be a little bit confusing and a little bit unpredictable at times. This is why in this video we're going to explain how pack behaves by giving you many examples. Let's start by creating a couple of labels. And here I'm using TK labels as opposed to TTK labels, just because we don't need the themed or the styling of those labels at this point. So we're going to put two labels in the root. Okay, here we have two labels and we have placed them in the root. Now, if you remember correctly, whenever you run a code like this, you won't get anything in your window because you've not packed the components into it or you've not placed them. I'll say at this point that as well as pack, there are other algorithms for placing components in the container, but we're only learning about pack in this course. Let's give these labels some text. So I'll say label 1 and some background, which will be green. And the other one is going to be text equal label 2, and the background is going to be red. Then we're going to pack them. So the first one we will pack on the left, and the second one we will pack on the top. Let's run this here. You can see that they appear side by side, even though one has been packed on the left and the other one has been packed on the top. So what does side mean? Well, you can think of side as the anchor point to the component. And what that means is that this component, label 1, is glued to the previous component or the window by the left side of it. By contrast, label 2 is glued to the window on the top and not on the left. You can see that happens as you expand the window. The label 2 keeps being stuck at the top, but label 1 is stuck on the left. As the space expands, label 1 has no knowledge of vertical distance because it is glued on the left, so it always stays in the middle. And label 2 has no knowledge of vertical distance, so it stays on the left, as close to where it originally appeared as possible. Next up, let's use fill. So we will say fill equal y and fill equal x. Let's run this again. And now look at what happens. We have filled on the y-axis the left label. And that means that it now takes up as much vertical space as is available. So the background and indeed the entire label spans the whole vertical space. Similarly, label 2 spans the whole horizontal space, or as much as is available, but there is a gap here where the green label is. Because the green label was added first, it takes priority. So it fills on the y-axis first before label 2 has a chance to expand. If we do the other way round, putting label 2 first, then you'll see what I mean. So now label 2 is glued at the top, label 1 is on the left. As we expand this, you can see that label 2 now takes up the entire area because it